Circle, an impossible shape in the world of Minecraft, where all things are squares and cubes. However, many will still use the shape in a blocky form in their builds to give the feeling of realism, but turning a curvy shape into a shape made of blocks can be a daunting task. Well, you can't just search pixel circle or blocky circle on the internet. There is straight up a pixel circle generator on the first link. But hey, I like to know how to make these generator myself. Look, I made this sick underwater laboratory with the program I made. And I recently updated the program, so why not show it to the world because I'm dumb. Hello everyone, I'm Kingston. Today I'm going to show how I use Python to make blocky circles. Like any good programmer, we should start with how the program works. We can start with the circle itself. Luckily, graphing can make one easily by using x squared plus y squared equals to r squared, where r is the radius of the circle. And if we replace the equal sign with a smaller or equal sign, the graph will include the inner parts of the circle, which mean the xy points that are true within this equation will be inside this circle. Next is how do we know a block is in the blocky circle? There are two ways to do this. We can define a xy position of the square as the center of it. Then just use the equation we just found to know. Or we can calculate the area of the circle taken in the square to see does it take at least half of the area. For the program I made, I chose the first one, as the second one requires some really annoying integral calculation. Besides, the resulting blocky circle will be pretty similar. However, defining the center can be a bit tricky, since the center of this blocky circle can be different. It can be a block center or not, which can affect the actual xy position of each square center. If it is a block center, the position will be their coordinates essentially. If not, it will be 0.5 units off. Lastly, how would the program find the squares that are part of the circle? We can have the program start at the top of the circle and check the squares along the x-axis. When it finds a square that is not a part of the circle, it will go down one square and continue the cycle from there until it reaches y equals 0. That is what my previous program did. But this time around, I just have my program find the protruding parts of the blocky circle. By rewriting the equation from before, we can use it to find x using y. So by doing it on each layer, we can find all the protruding parts of the blocky circle, and they can be used to form the circle, which is a lot faster. By the way, we just need a quarter of the circle, as you can just mirror it based on the center of the circle for the rest of the circle. Now that is all out of the way, I shall show you my program. So this is my program. Some keen-eye viewer might question, why the heck am I in the Minecraft files? I will get it very soon, but first let's take a look at the program. Let's start with the first two functions. These two functions are used to present the blocky circle visually. This function just prints out hashtags on the terminal to visualize it. This function is a little special though. It is also the reason why I'm in the Minecraft folders. There is a thing called functions in Minecraft, which lets you execute a list of commands at once. And this function creates a Minecraft function folder that lets me create the circle in Minecraft, which is quite convenient. Next up is the circle function of the program. This function does what I said earlier, find the protruding points of the blocky circle. This circle function takes the radius and bcenter, which is short for block center, and then returns a list of xy points, which are the coordinates of the protruding points of the circle. So let's start testing this program a bit then. Well, for now I have this as default right now, so I have to change it. So let's just go over to the code and we can try something like circle and let's try to a a 5 diameter. So let's go with 2.5 and its center is technically the center. It is a block center. Now let's go and put on next one. Print and start. Oh, okay, try again. Okay, we got the printout right here. And also, if we now go and press the this button, we appear with a circle. Right, dope. Dope. Now let's go with something a little bit more bigger. Let's go with like a diameter. Go with a diameter of. Let's go with a diameter of. How about 31? No, 30. 30. Then that will be a radius of 15. Then this will be false. False. And then we'll go and print it out. And a really humongous print. Let's look at it. Print right here. So let's go and print. Let's go and test this out. A real big circle here. But hey, if I just keep showing you these, it will be kind of boring. So let's go with something more interesting. They seem to look like a lot better. Then let's just go with 1.14 to the power of x. That's totally makes sense. And then every moment, and then we will just shove it in the equation. So, vectoring, rolling. Let's go with the about. Let's go with the first 20 intervals of this I value. And then if we go and say the radius is equal to the I, we go to this 1.14, no, I point 4 to the power of I will get mixed print, and we'll add a extra, we'll put it as true as the center as true. Center is true, and just shove the I right here. Oh, sorry, not I, R. The R right here, and R right here, and let's go and see look we the value of I. Right, and we will have input so that we won't just slush everything out at once. Let's see. So first one is a L. And done. Okay, let's have a look what I made. I feel like you look exactly like what I thought it would look like. A trumpet head, the head of a trumpet. Or maybe a witch hat? Anyways, well, maybe we can make this a little bit better. Nah, it looks sucks. It's actually not bad in my opinion. It's sick in some way. Oh, maybe it's like a goo? A gooey substance dropping on a floor. Okay, I'm going off topic. Now that I've shown you a function that can make blocky circle, the video should have end here. But hey, since we have the function, why not go one step further? Make a blocky sphere is actually pretty simple once you have a function that makes blocky circle. After all, the sphere equation is just adding c squared to the left side of the equation. And doing some algebra, you can find the radius of each circle of each layer along the axis. And with that info, bang! The function of blocky sphere can be made by using the circle function. Okay, let's go and test out the sphere which would be this MC oops MC from print sphere. Let's go with number 5, and let's go with let's go with the center as false. That should create a diameter of 10 sphere, and we shall put it as true as 3D, true 3D, and the center as false. Thank you. False. And then start. As you can see, can clearly see it's found a lot of hashtag to simplify how you stack them. Now let's go and check out the function itself, and if I press the button, the sphere appears. Albeit a little chunky. I have maybe just the glass fault. Let's have a look. It is spherical, and let's check the dimensions. Exactly 10. Good. 10. Good. Now let's go and test out the other version, which is what it is a block center. For block center, let's just go directly 5.5. No, 5.1.5. 5, and let's just directly turn them to true, and put this as true. True, and then we'll just run it. Again, everything is right here. Should look quite similar though. See, I get a lot more better in color. Let's see, are there anything weird about it? Nothing. Okay, that will be it. There's legit nothing else to do with this, since I can't really move it well. Maybe I can animate it. Wait. And 11, 12. I need to get to 13, so let's just go over here. This thing is dangerous. Bro, this thing is dangerous. That way should not have a nuclear bomb in your inventory. Put it here. Okay. Ooh. That actually look quite sick. So, that will be all with circles and spheres. Boo! Did I scare you? Probably not. The runtime of the video has yet to end after all. Anyways, if the program only makes circles and spheres, it will be pretty pointless. Then what happens if you stretch a circle? You get an oval, or to be more exact, an eclipse. Wait, no. It's called an ellipse. And if you stretch a sphere, you get an ellipsoid. So, why not make some function to create those too? Here are the equation for both of these shapes. And by doing some algebra, we can find the value of x with all these variables. So here are the two functions. As you can see, they are pretty similar to the two functions I mentioned earlier. That is because they operate basically the same way as the last two. In fact, they can do the same thing as the last two, which makes them useless now. Okay, let's go and try out the ellipse and ellipsoid one. So let's go to here and start it. Now let's go with McPrint. My thumbprint. Now we'll go with ellipse. Ellipse, and we'll go with a ratio. Go with a 1 to 2 ratio. 1, 10, 5, 10, 5. How about that? No, 5, 10, so 10. And then we'll get in this case, B center will be false. False. Now let's go inside it. Put in the other one. This is false. False. And false. False. And run it. And we have it right here. Now we go to Minecraft and press it. We got this. And dimensions. No, I'm not gonna check. Now, if I do something a little bit more, I'm gonna try something. So if I go to here, let's go and go and add a little bit in here. Make one. Now this time, let's go with something like something through, 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 and let's go. This time we'll go with a also 1:2 ratio. Let's go to 2.2, 2.5, 2.5, and let's just go with 5.5. And now if we print it, oops. Anyways, we got something like this. Looks a bit odd, but I think it's correct. I think it's correct. And then if we go over, and if we go back one step, we've already changed this. Now let me reprint this. Now we got something like this, and now we'll go and quickly replace these with black and white concrete. You know what am I doing? Go over here. Let's go white concrete. Replace new stained glass. Ah, that's a lot faster. Now we got AI. Cartoonish. AI. Cartoonish. Let me place this in there. Feel it. Now let's go to the other one. The other one. Go to the another one. Okay, so let's go from ellipse to ellipsoid. So, and you have three variables that I need to enter. Let's go basically with adding a 5 here. And then false, false, false. Nope, this one is true this time. True this time. And we get this. Let me turn it into an egg. Can I? Wait. No, actually, just now it won't look like an egg, right? Guess I'll try to see does anything look like one. How little it be? Uh, okay, a little bit further. I gone to, did I not gone low enough? I did go low enough. And then this side, I think it should be fine enough. I'll do the exact same thing. Do the exact same thing. What color? What color? Wait. White terracotta. Apparently that looks like one. White terracotta will go and replace blue stained glass. No. Yeah. Blue stained glass. Oops. Ah, you see things. That is not the z-axis. It is on the x-axis. Now it looks like an egg. Not sure. I'm not sure why did I even make this. Why did I even make this? Why did I even make this? Now let's go. The last variant to complete this. The other variant is if it is a block center. And then we'll need a 0.5 for the digits. Actually, let's go with something more unusual. 10.5. Let's go to 0.5. 5. Actually, here we'll put as 12. No, no. 10. No. I think 5 is good. 5.5. And this one 5.5. However, this one will not be 5.5 and it will be 17.5. And it out and how weird it looks. Hmm. And press. We got corn. Guys, block centered. What can I do with this? I mean, I can do something real quick. I know it looks simple, but it looks pretty much what I was looking for. That will be it for the video. I've added the main parts of the program to the description below and included a user-friendly-ish function There's definitely more things that these functions can do, like making a comb, but I'll leave it to you to figure it out. If you have any ideas of improvement for the program, feel free to comment below. After all, I'm not a professional. Anyways, see ya!